Hey everybody, maybe you just watched my last video where I almost got cut off at the end, so I'll try and be faster this time. So this is one more example of how to calculate total mechanical energy and compare things. So we've got two cars of equal mass. We went over this diagram. Should be in your notes from last week. But this time we're going to use a different reference height, so it's going to be a little different. So anyway, we have car A that's moving in the basement at 10 meters per second, and car B is at rest on the second floor. And we got to figure out which car has more mechanical energy. So I'm going to set my reference height down here today. And that's going to be H equals 0. This thing, it just takes too long, my friends. Okay, that's a big O, 0. So that's where H equals 0. So this guy down here is not going to have any GPE because it's on our height of 0, but it is moving, so it's going to have KE. Okay, moving right along. We've got, so again, actually, in your notes, you guys said that car B was 10 meters above car A. So that's from last week. So if you're not really sure how we got that, basically, we're going from this line to this line, which is 5 meters, and then from this line up to this line, which is another 5. So we get 10. Okay, so we're going to go over here and we're going to start. So we've got car A. Car A is in the basement, so its height, we're going to write HA for height of A is equal to 0. We're going to write down that its mass, because they're identical cars, the mass actually of A is equal to, here it is, 1000.0 kilograms. And then we're going to write down that the speed of A, wow, that was fancy, is equal to 10.0 meters per second. We did need to check that all of these are in the correct sig figs. So sig figs for us are going to be mass should be in kilograms. Super, it is. All our heights are in meters, which is the sig fig for heights. Or sorry, not sig figs, SI units. So the SI unit for mass is kilograms. The SI unit for height is meters, and the SI unit for speed is meters per second. So we are all set with that. Also for car A, we want to know E total. Oops. So I'm going to write E total A equals question mark, and we'll add to that for car B. And then here we're just going to write in our formulas. So E total equals GPE. You would think I would hit the right, I would eventually, there it is, hit the right thing. EPE equals, sorry, E total equals GPE plus KE. GPE equals MGH. KE equals, I'm going to use 0.5 again, MV, and then caret for 2, MV squared. So that's 1/2 MV squared. All right, so we're just calculating total mechanical energy for A, which is just kinetic energy. So we're going to go here. We're going to write down GPE equals 0. Okay, KE equals 0.5 times our mass, which is 1000.0, 5 sig figs there, times our speed of 10.0 sig figs, 3 sig figs, squared. All right, so when we calculate that, we get, all right, 10 times 10 is 100. 100 times 1,000 is 100,000. Half of 100,000 is 50,000. 50,000 joules. It's supposed to be in 3 sig figs. I just am going to have to write it in 3 sig figs. The reason it's supposed to be in 3 sig figs is because of this 10.0 having 3 sig figs. So do 5.00 times 10 to the 4th joules. And that is our answer for that. I'm going to check out if we need to brush up on scientific notation. Also, I try to make it so that you need to use scientific notation, but obviously I didn't do that this time. All right, so now we're going to go over here to car B. And before we do anything with car B, we always write things down on the diagram. We label the energy types. This is not moving, so there's no KE, but it is 10 meters above car A. So it's going to have a height of 10 meters. So it does have GPE, right? So all we're looking for, if it has GPE, is whether or not it has height. All we want to know about KE is whether or not it's moving. So here we go. So we're going to write down that the height of B is equal to 10.0 meters. And again, if you're like, whoa, where'd that come from? Check your notes. The mass of B, nope, is equal to it just says mass of car, and it does say two cars of equal mass. So they're just telling you the mass is 1,000. And fun story, you could figure that out by yourself. You don't even need that. And then V of B is equal to 0. I forgot to put in here that G equals 10. So G equals 10 in both of these. I'll write it here. It's going to go down, isn't it? Whatever. We'll take out a couple. Whoa, hello. Well, whatever. I'll move this over, and then it'll have room. It'll have room. Yep, there we go. Fine. Okay. The other thing we're asking for in our U is E total B. So we're looking for total energy. And we already did all of our units. So now we're going down here and we're writing down that our GPE is equal to our mass, which is 1,000.0, times G, which is always 10, times our height. Our height is 10.0 meters. So we're going to need to be in 3 sig figs. I can already tell. This is another scientific notation, which is awesome. Who doesn't love that? So that's equal to 1,000, and then you add another 0 and another 0. So that's going to give us 1,000. That's 1,000. One more 0, one more 0. I'm going to go back and add the commas. I'm going to make you guys do that because I hate to try and read without the commas. So without sig figs, it's easier to compare. This is 100,000 joules. That's only 50,000 joules. So this one's actually going to be higher. But I am, like I said, gonna put it in the correct sig fig. So I should just do 1.00 times 10 to the 10 to the 5th. Here, I'll hit enter so it's easier for you guys to see. So that's the correct answer with correct sig figs. Our KE is equal to 0. So actually, for both of these, I should have put down E at the end. I should have put down E total. So 1.00 times 10 to the 5th joules for this one. And over here, this was 5.00 times 10 to the 4th joules. So really, we should be able to figure out which one is bigger. This one is times 10 to the 5th. This one's times 10 to the 4th. That one is bigger. So maybe you were not expecting that. But that's how we got that answer. So we should have that car B. I'm going to just put this down here. Car B has more E total and car A. If you think about it, right? So we, over here, we took that same mass, right? And we multiplied it by 100, and then we took half of that. Over here, we took the mass, same mass we used before, and we multiplied it by 100, but we didn't take half of it because it just so happened that the height was equal to G. So we multiplied by the same 100 that we multiplied with over here. If one time, actually, I could say what speed would car A need to go in order to have more mechanical energy than car B? That would be a good problem. Maybe I'll give you guys that one day. But car B has more E total than car A. Usually it doesn't work out this way, but this one did. If I sound surprised, it's because I haven't done this problem since last year and I didn't realize. I was not expecting this. All right, everybody. I hope you enjoyed your notes. See you later.